Okay, no joke. I just recorded this and the microphone wasn't on. So if you can imagine, I'm super happy right now to record it again for you, because why not? Oh, I'm in my laundry room, see? I'm going to record it again for you. I am super happy about this. I just love recording about linear functions. It brings joy to my heart and to children everywhere. So you get to hear it again, and I'm so happy and excited about it. Not at all, but I love you, so I'm going to do it again. Yeah, awesome. Hey, did you know that I miss you guys? Because I literally sit here talking to myself in my laundry room. Look at this. Oh, wait. And recording. I put that laundry away. Yep, and here's my sheets. See, look at how pretty they are. Enjoy that, because guess what? I look like I write like I'm in kindergarten on this tablet. It's awful. You're welcome. But the notes that I just showed you, those lovely color-coded notes, will be available in Classroom, and you can go look there and not have the awful notes that you'll see right away here. Okay, I'm going to record again because I just love it so much. It's my favorite thing ever. It's just super fun. Linear functions are what we're going to start with. I'm going to do a video on linear, a video on quadratic, a video on cubic, and then you'll have them each separately so you can watch them. Or you can just go to the notes and look there if you get it and you're like, I don't need to listen to you 3 times, Lepp. Not today, okay? If you're like that, you can watch one and then understand it and be like, got this. Or you can watch 2 of them or 3, whatever you want, or none. Those are your options, okay? Up to you. So linear functions, which we did in grade 11. But we did them first in grade 10. We kind of looked at them a little bit in grade 11, mainly quadratics. We really hit home quadratics in grade 11. But in grade 10, we did linears a lot more. Okay? So in the linear function, we're going to look at the parts of it. This right here. Oops. Didn't put that in the right spot. On this x, there's an exponent of 1. Okay? That exponent 1 tells me that this is a degree 1 function. Look for the kindergarten handwriting. It's coming out. Degree 1 function, which means it's an odd degree. Okay? Odd degree functions, end behavior, so how the arms end on the left and on the right. End behavior will be in opposite directions. So for example, if it's up on the right, it's down on the left. If it's down on the left, it's up on the right. If it's up on the left, it's down on the right, etc. Okay? This lovely thing here, this value in front, which we often called m in grade 10 because it's our slope, it's also our leading coefficient. This writing is so terrible. Leading coefficient. Boom. Okay? Our leading coefficient tells us how the graph ends on the right. The sign of it does. Okay? So if a is greater than 0 or positive, I don't care what the number is, if it's positive, it ends up on the right. Awesome, it's clicking. I'm sure you get to hear that awesome clicking. You're probably loving it right now. If a is less than 0, it's negative, which means it ends down on the right. handwriting is so bad, it's actually making me a little crazy, but I'm going to work through it because that's just what we got, okay? The last thing we want to look at is the B, okay? That B is called your constant. And why is it a constant? Because it's the number without a variable. It's a number without a variable. It is also my y-intercept, always. This only works because our equation has no brackets. And when we're solving for y-intercepts, we fill 0 in for x, right? And if I filled 0 in for x, everything but the number without a variable would go away. So that's why the number without a variable is also, the constant is also your y-intercept, always. Okay? So we're going to look at an example. The example we're going to look at is y equals negative 3x plus 7. Okay. First thing we're going to look at is this negative 3. That means our leading coefficient oh my gosh, I have to back up. That's just so awful. I don't think it's going to get any better. Coefficient is negative. Right now I don't care about the 3. I just know that the leading coefficient is negative. So this graph ends down on right. Okay. Now this is a positive 7. Not sure why I wrote that out. Oh my gosh. The constant equals 7. So you have a y-intercept. At 0, 7, because the constant is the same as y-intercept. So the first thing we're going to draw when we draw this, try again. While I'm drawing this, I just want to say to you, that right now I can hear my daughter. They're just like a free-for-all in the house right now, so it's like Lord of the Flies here, but I can hear my daughter, and she is messaging with her grandma, my mom, on Facebook Messenger, and there's one positive of all of this. They're getting to talk more, so we have to think of some of the positives. So remember, if you're bored and you're like, what should I do? What should I do? Maybe give your grandma a call, you know, or give someone you know who's stuck in their house a call, because they would love to hear from you. Okay, so 0, 7. If y-intercept's the first thing we're going to draw. 1, 2, 3, 4, 5, 6, 7. So we draw our y-intercept. And then from grade 10, we know that this negative 3 is our slope. And we always rise before we run. So we're going to go down 3, right 1 from our y-intercept. So that's why we have to draw our y-intercept first. If you forget how to draw it, you can always type negative 3x plus 7 into your y equals, right? And then go second graph and get a table of values and sketch it that way as well. Okay, it gives you your x and y's. But we are smart and we know how to do this. So we're going to go to 7, and then we're going to go down 3, 1, 2, 3, right 1. And plot a dot. Down 3, 1, 2, 3, right 1. And then this is where it gets sketchy because I have to try and draw a straight line. Pretend that went through all the different things. Okay? So let's check and see if what we said is true. We said that because B, our constant is 7, we have a y-intercept at 7. Yep. And we said because the leading coefficient is negative, it ends down on the right. Does it? Yes. And because it's an odd function, I know then that it ends up on the left, only because it has to end in the opposite direction, right? What's great about linear functions is that their arrows are in opposite directions. So unless it's a word problem, your domain is always going to be x such that x is an element of the reals. And your range is always going to be squiggly bracket, because that means the set of y such that y is an element of the reals. And that's going to happen for every linear because the arrows are in opposite directions, okay? The last thing we have to go over is if I ask you for end behavior. End behavior just means you need to tell me how it ends, in what direction, okay? So the end behavior of this graph is up on left, down on right. Okay, let's go to some more examples. So I'm going to type this because my writing is so stinkly messy. So given the graphs of the following, determine the sign of the leading coefficient, leading coefficient, and the constant of the equation y equals ax plus b. Okay? Look at how much nicer that is than my writing. All right. So, A. So we have graph with a y-intercept at -3. So that's all I'm going to sketch for now. And a positive slope. So it looks something like this. Okay? So we need to tell the sign of the leading coefficient. The sign of the leading coefficient depends on how it ends on the right. So on the right, it ends up. So I have a positive leading coefficient. Oh my goodness. So because of this, I have a positive leading coefficient. Okay, now this here is my y-intercept, and it is at -3. So what does that mean? I have a constant of -3. And the constant in this case is b, right? The letter that's in the constant form. So what does that mean? That means b, little b, equals -3. Okay? Now let's look at example B. So now I have a y-intercept of 4 and negative slope. So what does that tell me? So here I have a y-intercept of 4. So that means I have a constant, try and write again, of 4, or my b value equals positive 4, right? Because it's a positive 4. I also have an arrow going down, so that means I have a negative leading coefficient. So because it's down, I have a negative leading coefficient. So what does that mean? A is less than 0. And in this case, my leading coefficient is -3. Or sorry, my leading coefficient is positive, so A would be up here. A would be greater than 0. Okay, last thing to go over, possible number of x-intercepts. So for linear graphs, you either have a line like this, or you have a line like this. You could have a flatter line. But no matter what, you will always have at least one x-intercept and at most one x-intercept. You will always have one x-intercept. So with linear functions, you always have one x-intercept. Always. You can't have none, you can't have more, you have one. That is all for linear. So I'm going to do quadratic and cubic as well as separate podcasts. But if you get the idea, you can just go look at the notes and maybe not want to watch those. Or maybe you think, wow, your voice is so soothing, Lepp. I just can't wait to listen to the other two. This is riveting. Maybe that's you. I don't know. I'll leave it up to you. Bye.